Here we're going to discuss different types of acid reactions, so where you have acid and you react it with something else. Now the first thing you need to know is the three main acids you're going to be using, and that's hydrochloric acid, sulfuric acid and nitric acid. And in order for you to understand the products given off from these different reactions, it actually helps as well to know the symbols. So hydrochloric acid is HCl, sulfuric acid is H2SO4, and nitric acid is HNO3. And this is useful, as you'll come to see later. Now what you can notice about this is they all contain the hydrogen ion. And that's actually what makes these acids, that when they go into solution, the H plus ions dissociate. So we'll discuss this later. So the first reaction we're going to look at is a general reaction where you add an acid to a metal and it will form a salt and the gas hydrogen. Now an example of this reaction would be hydrochloric acid, add magnesium. Now what would this form? Well, my salt would be formed from part of my acid and my metal. So my salt would be magnesium chloride and hydrogen. Okay, now a good way to always check this is by using the symbols as well, because obviously when you have a reaction you can never create new atoms or destroy them. So if I've made up something here, I'm going to be able to spot it. So hydrochloric acid is HCl, magnesium is Mg. So magnesium chloride, MgCl, it's actually MgCl2, and hydrogen. Now, it's not quite balanced yet, but what I can see is I haven't just made up some parts. I've got hydrogens on both sides, I've got magnesiums, and I've got chlorines. So all I would need to do now is to balance it, and to balance it, I would just need 2 lots of HCl there. So I'm happy with that. Now there's an example. Another thing you might notice is that I've called this magnesium chloride. Now the chloride, ide means there's 2 parts to it. So the 2 parts are magnesium and chlorine. So when we do our next example, you may see something slightly different. So if we change the acid and we have sulfuric acid and we add magnesium, remember the only change is that I'm changing the acid. I would still have a salt formed and I would still have hydrogen formed, but my salt would now be called magnesium sulfate. It would not be called magnesium sulfide, and I'll explain why in a minute. So again, the best way to kind of go through this is by looking at the symbols involved. So sulfuric acid is H2SO4, add magnesium, makes magnesium sulfate, and hydrogen. This is actually balanced already, so I don't need to balance this. But the question is, why is this called magnesium chloride and this called magnesium sulfate? Well, the difference, hopefully you can see, is the ide has 2 parts, magnesium and chlorine, and the 8 actually has 3 parts. It's got magnesium, sulfur, and oxygen. And this has come because you've used sulfuric acid, which contains the oxygen. So whenever you use sulfuric acid, the ending of your salt will always end in 8. Now this is the same for nitric acid, because as you can see, nitric acid is HNO3. So if I use nitric acid instead, it would be magnesium nitrate, not nitride. So there we have example 1 of our first acid style reaction. Acid and metal makes a salt and hydrogen. The second style we're going to look at is where you have an acid and you add it to an alkali or a base and you form a salt and water. Now, this type of reaction is actually called a neutralization because the salt will be neutral and the water is neutral as well. So you're actually starting with something with a pH less than 7, the acid, and a pH above 7, an alkali or base, and producing neutral products. So let's do some examples. The most simple example is hydrochloric acid as your acid and sodium hydroxide as your base. The products, well, I know one product will be water, and if I'm not sure of the product, I can actually hopefully work it out using the symbols. So HCl, sodium hydroxide is sodium is Na, hydroxide OH. Water I know is H2O, so if I'm using H2O, that will leave me now with sodium chloride. So NaOH and sodium chloride. It balances. I've not created new atoms, I've not lost them, and I've formed a salt, sodium chloride, and water. Slightly different, but based on the same theme as the first one. If I used nitric acid instead and added it to sodium hydroxide, I would still form water, and I would still form a salt, but now my salt would be called sodium nitr. Now the nitric acid, remember, has an oxygen in it, so it would be called nitrate. Sodium nitrate and water. Using the symbols to check that. HNO3. So sodium nitrate would look like this. And I've got my water produced from the hydroxide ion in the alkali, and the H plus ion in the acid would form the water. So hopefully again you can see when you use sulfuric acid and nitric acid it ends in ate. When you use hydrochloric acid it ends in ide. There's two examples of that type. We'll now move on to another type. Now the third type is another kind of spin-off from the second type. So type 2 we said was acid and alkali. Well, we can actually expand on that a bit further. So the alkali that I used was sodium hydroxide. So sodium hydroxide, sodium's the metal, and hydroxide, the anion part. Now that makes an alkali. Now a base is very similar, but it's most of the time they are insoluble in water. And so instead of using an alkali which is soluble in water, I could use a base which is a metal oxide. For example, calcium oxide is a base, and it will react just like an alkali would, because it's acid. Add calcium oxide would form a salt and water. Now there's one final example, which hopefully using the same kind of the reasoning that we've been going through, you might be able to spot yourself. And that's what happens when you add an acid and a metal carbonate. It will always form a salt, and it will always form two other products as well. And I'm going to see if you can spot these in a moment. So, for example, let's start with sulfuric acid. And let's use calcium carbonate. Nice simple one. So I'm still not 100% sure what I'm producing, so I'm going to put in these symbols. Now my salt is formed from my metal and the acid that I use. So my salt will be calcium sulfate. Remember, sulfuric acid makes sulfates, which would be this. Now my other products, well, I've still got hydrogens needed to be used, I've still got carbons needed to be used, I've still got oxygens needed to be used. So hopefully you could see that you would produce water, which would use those, H2O. However, I've still got this carbon to use. So whenever you react with a carbonate, you're going to produce the gas carbon dioxide. Now to me that kind of makes sense, because when you look here, you've got to use this carbon somewhere, and it's not in the salt. So therefore, most likely you're going to produce this gas. So if you did this reaction, you would actually see bubbles, you'd see fizzing, and those bubbles would be carbon dioxide bubbles coming off. Now looking at this here, you can see that it's actually already balanced. My H2 has gone to my water, my sulfate has created the salt, my calcium has created the salt. So then here, one of the oxygens has gone to make the water, and the other two oxygens have gone to here with the carbon to create carbon dioxide. So everything's balanced. They're the four reactions. Key things to remember are you've got three different acids. Hydrochloric make chloride, sulfuric and nitric make sulfate and nitrate. And if you use your symbols and you don't create new elements and you don't destroy them, hopefully you'll get a good understanding of what's going on there. But it is about practice, so good luck.